Greetings and welcome, mis amigos, mis compadres, los estudiantes. But really, if you think about it, we're all students of life, aren't we? We are. I like to think so. So yesterday we were talking about the boxes and the whiskers. It's amazing. So here is a homework question that I'm going to go over with my friends, and maybe they'll have some questions, maybe they'll have some feedback. That'll be great. So it says the following: use the box and whisker plot. I almost said flot. That's not a thing. To find the given measure. So what is the least value, friend Migos? Yeah, 3. See, you're an expert at this already. Expert. Question 4. What is the greatest value? Un otro amigo. Another friend. Hey, heads up. Follow along here. I'm on question 4. Yeah, Jake. 14. And you found that by looking there. Now, I'm going to skip to question 8 for a minute, because these are related. What is the range? Also. The range is simply going to be the total width of the box and whisker plot. Range does not measure the center of the data. It measures how spread out the data is. So the larger the range, the more spread out it is. Okay, let's see. Before we find 5 and 6, let's find question... Oh, actually, no. In this case, it doesn't matter. Let's find 5. What is the third quartile? Third quartile. Ben. Okay, all right, thinking. Right. Just like the meme when the guy's got his finger on his temple and he's like, right, you know what I'm talking about. Jacob, you're saying 11? I agree. Yeah, that's Q3. All right, first quartile. Let's see. So first quartile, yeah, Kaylin. 6, and Ricky, I'm going to ask you to figure out the median for us in a minute. So let's see. So the first quartile is right here. That's the 6. And the median, what are your thoughts looking at this, Ricky? You have an idea? All right, Jacob, make sure you're writing it down then, Ricky. Jacob. It's the 8. Yeah, the median is right here. So in terms of this, so this is the low point. Actually, I'll write that even in outro color. So here's the low value. Here's Q1. Here's Q2. Guys, shh, don't distract each other. Which is the same as the median. All right, you can call that Q2. Here's quartile 3, and here's the highest value. Okay? And the value of a box and whisker plot is that it tells us that 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. Now, that's not super interesting for this one, other than the fact that this is a smaller width, right, Jake? Smaller width versus this one, which is a little bit wider. So that tells me that the data is more dense in here and more sparse in this region. Okay, so it would be spread out a little bit more. Okay, so if you have two of these kind of boundaries super close together, that means there's a lot of data that's compact in there, versus if it's a really long section, it would be spread out. So let me ask you this, actually, bonus round. What % of the data is 6 or more? With the win, Maya, I like it. What %? I was maybe still writing the question or listening to the wrong answers. So if I want to know what % of the data is 6 or more, that's just going to be the sum of 25 plus 25 plus 25. That is a mondo 75% of the data is in this region. Okay? So 75%. So that is one of the types of analyses that you could do with a box and a whisker. All right, let's make a box and whisker. You just done doodly it? What? All right, let me arrange this in order first of all. 0, like 2, I got 1, 3, Let me cross those out. 2 4s. All right, we'll follow along. Make a correction. Use your different colored writing utensil. Oh, with the save. That's why we're friends. You know what? A friend is faithful to tell you something that, even though it might hurt a little bit, but it's true, and I appreciate that. Faithful are the wounds of a friend. You know that? But deceitful, those are the kisses of an enemy. If you're just flattering me, telling me, you're great, Mr. Waddy, and then I'm messing up the whole time, that's not friendly. Here we go. Thank you, with the save. So, the first thing I'm going to figure out is the median. All right, so yeah, 2's not, yeah. So then rearrange it, make a correction now, yeah. All right, so if I want to find the median, what do I do? Yeah. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like these two values will be in the middle. So when there's two numbers in the middle, I average them, and the average of 4 and 4, you guys can probably guess, is going to be 4. Yeah, isn't that great? Yeah. So if I want to find quartile 1, ladies and gentlemen, I take the first half of the data. Question, is this the first half of the data? Or do I include this 4? Yeah, because there were two guys, listen, track with me. Because there were two numbers in the middle, I do choose to divvy up those numbers between first and second half, okay? So, so that's the first half. This is the second half. Quartile 1 is going to be the median of the first half. So of these 4 numbers, what's in the middle? 2 and 3. Yep, so 2.5 is quartile 1. Well done. And of these, there are 2 numbers in the middle, so quartile 3 is, yeah, the average of 5 and 5 is 5. All right, question, easier ones. What's the lowest value? 0. I like it. Any questions on this so far? Yeah. No? Good? Yeah. All right, so now I've got this little number line here, and I'm going to label some of it. You don't have to label all of it. I should include the numbers that go from my lowest to my highest, though. Okay, so I'm gonna start here at 0, 1, 2. I know I'll throw a -1 there, just because, hey, negative numbers exist, friends. They're real. Yeah. 7, 8, 9. You don't necessarily have to label all of them. I could have labeled every other, whatever you want. Okay. Yeah, question? I look at the completion of your homework, although the grade does not numerically affect your score directly. It indirectly, that practice does correlate to doing better on tests. Yeah. So I still track that. But this is not a question for right now. Let's take a look at this. So box and whisker. I'm going to put the endpoint of a whisker at my low, an endpoint of a whisker at my high point right there. And I'm drawing it kind of like in the region above the graph here. I'm going to draw a vertical line at my quartile 2, a vertical line at quartile 1, which notice should be roughly... Guys, are you with me here? I'm just hearing some noise pollution is all, you know. Let's end the noise pollution. You know what I'm saying? And here we go. So I draw a box around Q1, Q2, Q3. And then I draw me some whiskers. So question. Based on my box and whisker, where is the data most densely populated? Here, Kaylin, what are your thoughts? Yeah, I've got 25% here, which is that's 1 unit wide, and 25% here, which is, it was a tie, intentionally a trick question. So between 4 and 5 and 5 and 6, I also could say 50% of the data was between 4 and 6, right? Where is the data least densely populated? Least dense. Now, this is the longest section that represents 25% still, and it goes from 0 to 2.5. So, guys, 25% of my data is between there. It's a little bit denser between here, and then it's most dense between these two, and it's a tie as far as their density. So I just want to kind of like relate this to the idea of how spread out or dispersed the data is. All right, some quick analytical questions here. Rapid fire. Bam, 15. Find and interpret the range of the data. What's the range? 18.25 minus 8.75. All right, guys, I'm going to... It's okay. 9.5 is the range. This is price in dollars. So this represents prices of entrees at a restaurant. Yummy. That means prices vary by $9.50. Okay, that doesn't mean that the cheapest entree is 0 and the most expensive is $9.50. It means that the difference between the cheapest and the most expensive is $9.50. Describe the distribution of the data. I might say, here's something I notice. Most, or let's just, yeah, I'll just say this. 25% of entrees are between $13.25 and $14.75. All right, that's the most densely compacted range of entrees. Entrees are, right, your dinners. Let's see. What's another random fact that you could tell me about this distribution? I could say 50% of entrees are less than what? Yeah. Okay. All right, so by looking here, I can see that, right, 50% is this way, right? So it kind of gives me an idea of where these values are located. It says, find and interpret the interquartile range. Do you guys remember what that was? How do I find that? Okay. Is that 4 1/4? So, so that's the interquartile range is the difference between Q1 and Q3. Okay. And I would interpret that by saying that 50% are between 1050 and 1475. Are those like helpful comments being made over there because someone had a question? Or is it just noise pollution again? Man, we got a noise pollution problem, guys. This ain't good. Let's see. All right, question D. Are the data more spread out below Q1 or above Q3? So 25% are here, 25% are here. Where is it more spread out? Above Q3, right? because it's a wider range between Q3 and the highest point. Okay, so do you guys understand how I concluded that? Right, I looked at it, and I was all like, yeah, that data, it's more spread out in that area than the t'other. Are you writing this down, Jake? All right, really? All right. Okay, I'm going to skip 17. I want to look at 25. 21. Yeah, it's all right. 21, friends. Identify the shape of the distribution. Okay. So if I'm analyzing the shape of each distribution, okay, this is longer and this is longer than the other side. Okay, because the right-hand side is longer, we will call that skewed right. Because the right-hand side is longer. S-K-E-W-E-D. Yep. I believe it. Okay. Let's see. What is the range of the upper 75% of each brand? Okay, so upper 75% would be from here on and from here on. Okay? Well, actually, I guess they technically end there. So, guys, what's the range of brand A for the upper 75%? 7 minus 3.5, what's that equal to? I believe it's 3.5, right? And for B, what do I do to calculate that? Where does this appear to be? Ooh, yeah, right? 5.75, and I'm subtracting, where does this appear to be? Yeah, 3.5. What do these numbers represent again? Anyone read these units yet? The hours of battery life. I think these are cell phone batteries. I believe Dimitri Martin says a joke. He says, batteries are the most dramatic of objects because when they stop working, they die. Man, isn't that crazy? So guys, 5.75 minus 3.25 is 2.5. Okay? It says compare the interquartile ranges. So guys, interquartile range is going to be from here to here and here to here. All right. Interquartile range for A is going to be, that looks like 4.75 minus 3.5. Yeah. So that's 1.25 hours. And for Bravo, looks like 4.25 minus 3.25. So that's the middle, the interquartile range represents the middle 50%. Okay, so that's, yeah, 1, or you could call it 1.00 if you're really cool. Yeah. Okay, so compare those. Brand B. B is more densely located about the mean. Or median. All right, that describes the variability because it's, right, more compact, that their brand B, you could say batteries are more consistent in their battery life than the other, even though they have a lower median value, okay? It says, which brand do you think has a greater standard deviation? This is a conceptual sort of thing. Greater standard deviation. Remember, a greater standard deviation means data will be more spread out. So A, it is more spread out. Yeah? You guys agree? Are you tracking with me? All right, now here's a real world question. You need a cell phone that has a battery life of more than 3.5 hours most of the time. Which brand should you buy? Really? In terms of, are you referring to their battery life? Actually, all right. Let's see what the old Consumer Reports tells us. Ooh, wow. Okay. Uh, battery capacity. All right. Okay. Okay. And they're not even for talk time. If you're only talking, remember your screen is off when you're talking on a phone. It should be. You've never noticed that when you move the phone to the side of your head, the screen shuts off. Yeah, it's kind of like a refrigerator light. Did you know that your refrigerator light shuts off when you close the door? Because you don't hide in a refrigerator ever, kids. That's dangerous. Okay, so I don't, guys. Hey, I don't even see Apple on this list. Okay, all right. You're saying in general. So anyways, what they ended up having here, I'm assuming these are average battery lives. And actually what's interesting is, look at this, the Samsung Galaxy S7 Edge actually has a bigger battery capacity, but it's only second best for battery life. Could someone tell me why they think that might be the case? Right? It's got more capacity, but somehow the technology must be using it faster. All right, maybe they're throwing some more pixels on that screen, some more lumens in that brightness. You know what I'm saying? Yeah, maybe. But in terms of our problem, someone answer for me the question: which battery has that has a battery life more than 3.5 hours most of the time? So here's 3.5 hours. Look at this. For B, I've got 50% of the time it will have more than that. And for A, I've got 25, 25, 25, 75% of the time. Right? So phone A has more than 3.5 hours 75% of the time. So wait, are you suggesting you're using your phone the whole school day? So is your phone on right now? Exactly. Mm-hmm. Anyways, mis amigos, thanks for watching. Adios. And that was